Okay. Today we are just going through example 1 and example 2. So I'm trying to find a piece of paper here. There we go. Okay, so if you would turn to example 1, as a review of what we talked about in class today, we started talking about logarithms. We'll talk more about the connection between logarithms and exponentials tomorrow. But what we're working on in this video specifically is working with the properties. So we are going to work on expanding, which is to take something that's condensed like this that has one argument and break it apart into separate terms. We're also going to work backwards and take two or more terms and condense it into one logarithm. So again, these two examples are just working with the properties and getting comfortable with those. So if we start with example 1, make an A and a B. And under A, I want you to write this expression. Okay. Now, this is one logarithm all put together, so we are going to work on expanding. So above, like where it says example 1, write expanding next to it. And then there is a certain order that you have to follow to make sure that that you do each, or you expand each part of it. So the little acronym that I use is DMP. D stands for division, M stands for multiplication, P stands for power. So the first thing that we're going to do is look for division. We clearly have division between the numerator and the denominator. So we're going to break apart the division by using the quotient property, and we're going to break it into two separate logarithms with a subtraction sign in between. Okay, so there's the first one and the second one. Notice I have an argument with both, a base with both, and log written with both. So you're taking the one, breaking apart the division into two terms. Then you look for multiplication. So we look at both arguments here, and here I see actually three things being multiplied, 3x squared and y. So we're going to break apart that argument by using the product property, and we're going to break that apart into separate terms with addition signs in between. So this is going to convert into 3 logarithms with addition signs in between. Okay. So we've broken apart division, we've broken apart multiplication. The last one that we look for is powers. So I see two things that have exponents on it. This part's the easy part. Those just come out to the front to fully expand. So your final answer will be log base 3 of 3 plus 2 log base 3 of x plus log base 3 of y minus 3 log base 3 of z. And that's the fully expanded expression. So you're taking one logarithm and breaking it apart into all the pieces that make it up by using the properties. We're going to do something similar for B. Okay, so we follow the same process, DMP. We're going to break apart the division. So numerator, denominator become their own arguments. You break it apart into two separate logarithms by putting a subtraction sign in between. Then you're going to look for multiplication. Well, we have two things being multiplied here, 2 and x cubed. Two things being multiplied there, a y squared and a z. So both of those are going to break apart into two separate logarithms. Now, the second one, since there's that subtraction sign in front, you do need to make sure you group them together so that you show both these are still being subtracted. The last thing I look for are powers. So we're going to bring those powers out front. We have log base 5 of 2 plus 3 log base 5 of x minus 2 log base 5 of y plus log base 5 of z. Now, example 2, if you flip the page here. Example 2, we are going to work with condensing. And actually, this one I can actually do in here. So condensing. And if we're working backwards, that means we're taking something that's already broken apart and putting it back into one term. So instead of DMP being the process I follow, I'm reversing the process. So I'm going to start with P, look for powers first, then multiplication, then division. Okay, make an A and a B. First one we're going to look at log base 3 of x plus 2 log base 3 of y minus 5 log base 3 of z. Notice the bases all have to be the same. We're going to start by looking for any powers. Well, I know something's a power if it's in front of my expression. So I'm going to make the 2 an exponent again and the 5, and then rewrite it. Okay. Then I look for multiplication. Well, I know things are being multiplied if there's an addition sign in between them. So to condense these two logarithms into one, I'm going to multiply their arguments together. So we have log base 3 of xy squared. And then the last thing you look for is division. I know something's being divided when there's a subtraction occurring. So in order to condense this one final step into one argument, this will end up being divided by this argument. So we have log base 3 of xy squared divided by z to the 5th. Oops. And so that's your final answer. Okay, let's look at one more. Now we haven't talked about ln yet. We will in a minute. Okay. So ln, notice there's no base here, but that's because ln stands for the natural log. So the base of the natural log is the natural base that we've already talked about, which is e. It's never written in. It's just you know that when you see ln, that e is the base there. We do all the same way. So we look for powers. Well, each one of these has a power. So I'm going to rewrite it and make all of those numbers powers again. Now this you could make a 4 if you want to, and I might in the next step. Then you look for multiplication. Well, I have 3 things being multiplied here because of these addition signs. So I'm going to condense all 3 of these into one expression and multiply my arguments together. And that 4 I'm going to stick in front here. Okay. And then the last thing I'm looking for is division. I know that these are being divided because of the subtraction sign. So to condense it into one final expression, this argument is going to end up being divided by that argument. So we have x cubed divided by 4y squared z to the 4th. Okay? So tomorrow you're going to get some good practice not only on the previous standards but also on condensing and expanding. And we'll take a look at the 4-type problems also tomorrow.